Hello and welcome to this tutorial on how to solve the 3x3 Rubik's Cube blindfolded using the old Pochmann method. This tutorial, which requires no prior knowledge, will be divided into 4 parts. In the first part, you will learn 3 short 15-move algorithms, the only main algorithms you will need to know, and the general order in which they are used. In the second part, you will learn the corner and edge face assignments and their associated mini algorithms that must be memorized in order to perform the solve. In the third part, you will learn the simple yet brilliant technique that ties everything together and allows us to achieve the seemingly impossible feat of solving a Rubik's Cube blindfolded. Finally, in the fourth part, I will go through a step-by-step example preparation and solve. Before we dive into things, I would like to note that while this seems like a very difficult skill to learn, the process of solving the cube blindfolded is actually fairly easy and can be mastered with enough practice. Initially, it may be hard to commit algorithms and face assignments to memory, but after learning the technique behind the solve, things will begin to make sense. On the screen is a list of all the terminology you will need to know. You may choose to write these down as they will be explained in parts 1 and 2 and referenced many times throughout the video. First, you will need to learn the 3 main algorithms that you will need to know. These 3 algorithms are called the corner swap, which swaps 2 corners, the parity swap, and the edge swap, which swaps 2 edges. For now, you can write them down as they will be useful later on. Eventually, however, you should commit them to memory and be able to use them upon will. The corner swap algorithm swaps the bottom front right corner of the cube with the top back left corner of the cube. Specifically, it will swap these 2 faces. This face is currently in what we call the prime position, and this face is currently in what we call the hit position. Therefore, when the corner swap algorithm is performed, the faces in the prime and hit positions are swapped. You will use this algorithm many times in the first half of the solve. You may notice that after this algorithm is performed, 2 edges are swapped as well. For now, you can ignore this. The parity algorithm swaps a series of pieces on the top layer of the cube. This algorithm is used only once if it is used at all, and it is used in the middle of the solve. Its function is to resolve the unnecessary swaps that occur when we use the corner swap algorithms. Later in this tutorial, you will learn where and how it is used. Here is a demonstration of the parity algorithm. The edge swap algorithm swaps the top left edge with the top right edge. Specifically, it swaps these 2 faces. This face is currently in what we call the prime position, and this face is currently in what we call the hit position. Therefore, when the edge swap algorithm is performed, the faces in the prime and the hit positions are swapped. You will use this algorithm many times during the second half of the solve. You may notice that after this algorithm is performed, 2 corners are swapped as well. For now, you can ignore this. Now you are ready to learn the cube piece face assignments. Start by holding your cube in this orientation, facing the green side with the white side pointing upwards. Notice that the cube consists of 20 mobile pieces arranged around a core, with 6 center islands around which the mobile pieces rotate. Of these 20 mobile pieces, there are 12 unique edges and 8 unique corners. To identify these pieces quickly during a blindfold solve, we are going to assign each edge and corner face with a letter of the alphabet. It is essential to familiarize yourself with these letter assignments, as recalling them quickly during the solve and during the preparation time before the solve will be crucial. With enough practice, the letter assignments will become second nature. First, we are going to assign a letter to the faces of the corner pieces. Starting on the white faces, we have A, B, C, D, followed by E, F, G, H on the green faces, followed by I, J, K, L on the red faces, followed by M, N, O, P on the blue faces, followed by Q, R, S, T on the orange faces, followed by U, V, W, X on the yellow faces. Notice that each corner piece has 3 letters assigned to it, each of the 3 faces, fixing its orientation in space. Also, notice that A is currently in the prime position and L is currently in the hit position. During part 3 of this tutorial, you will also learn the many algorithms associated with each of these corner letters. However, these many algorithms are logical and easily conjured at will, and therefore do not have to be memorized. The many algorithms are also listed in the description of this video for your convenience. Next, we are going to assign a letter to the faces of the edge pieces. Starting with the white faces, we have A, B, C, D, followed by E, F, G, H on the green faces, followed by I, J, K, L on the red faces, followed by M, N, O, P on the blue faces, followed by Q, R, S, T on the orange faces, followed by U, V, W, X on the yellow faces. Notice that each edge piece has 2 letters assigned to the 2 faces, fixing its orientation in space. Also, notice that B is currently in the prime position and D is currently in the hit position. During part 3 of this tutorial, you will also learn the many algorithms associated with each of these edge letters. However, these many algorithms are logical and easily conjured at will, and therefore do not have to be memorized. The many algorithms are also listed in the description of this video for your convenience. At this point, you have laid the groundwork for learning how to solve the cube. The actual process of solving a Rubik's Cube blindfolded is divided into 4 parts. Part 1 is the preparation phase, during which we will analyze the cube and memorize a sequence of approximately 20 letters using a nifty mnemonic technique that will be explained later in this tutorial. Then, you will put on your blindfold and begin the solve. In part 2, we will solve the corners by placing them in the correct positions and orientations by applying the old Pochmann technique. In part 3, we will account for a special parity case that occurs during half of solves. In part 4, we will solve the edges by placing them in the correct positions and orientations by applying the old Pochmann technique. The old Pochmann technique relies on a few simple principles. Although you will use the technique to solve both the corners and the edges, I will first explain how it applies to the corners. Notice that at any given time, each of the 8 corner pieces will occupy one of the 8 possible positions 4 corner pieces with a specific orientation. When the cube is solved, each corner piece will be in its correct position and orientation, called the final position. In order to solve the cube, we must move each corner piece to its final position. The way we will accomplish this is by using the corner swap algorithm from part 1 of this tutorial. When the corner swap is performed, the piece in the prime position is swapped with the piece in the hit position. Therefore, we are able to move the piece from the prime position to its correct or final position by performing a mini algorithm that places the current piece in the final position in the hit position, performing the swap algorithm that swaps the pieces in the prime and hit positions, then reversing the mini algorithm so that the piece that is now in the hit position is moved to its final position. This technique, which is a cornerstone of the blindfold solve, allows us to move each of the corners to their final positions in an efficient manner because the piece that was in the final position of the last swap before the swap is now in the prime position, ready to be sent to its appropriate final position. Therefore, we can simply memorize the sequence of letters that will be moved to the hit position during the preparation of the solve. Because this may be confusing and difficult to understand at first, here is a demonstration of the old Pochmann technique using only the corners. For now, we will go through each letter sequentially. Here I have a scrambled cube. You can replicate this configuration by performing the steps R, U, F, L, U, R. First, we turn to the face in the prime position and observe that it belongs in the R position, or its final position. In order to move it there during the solve, we will perform a mini algorithm to swap the final position and the hit position, then perform our corner swap algorithm, then reverse that mini algorithm. Notice that the corner is now in its final position. Again, we turn to the piece in the prime position. Notice that the final position for this piece is L. Because L is already in the hit position, we do not need to perform a mini algorithm. We simply perform the corner swap algorithm so that the piece is now in its final position. Again, we turn to the face in the prime position. Notice that the final position for this piece is J. We perform the mini algorithm to bring J into L, perform the corner swap algorithm, then reverse that mini algorithm. Again, we turn to the face in the prime position. However, we notice that the piece in the prime position has the prime position as its final position and is in the correct position but with a different orientation. We can resolve this by swapping this piece out with any other random piece that has not yet been solved. In this case, we can choose C, which is not solved yet. Mini algorithm, corner swap algorithm, reverse mini algorithm. The face in the prime position now belongs in I. We perform a mini algorithm to place I into L, perform the corner swap, and reverse that mini algorithm. Again, the piece in the prime position is in its final position. We can resolve this by swapping the piece out with W, which is still unsolved. Mini, corner swap, reverse mini. The piece now in the prime position belongs in T. Mini, corner swap, reverse mini. The piece in the prime position now belongs in P. Mini, corner swap, reverse mini. At this point, you may notice that of the 8 corners, 2 are still unsolved. Both of these pieces are in their correct positions, but not their correct orientations. To resolve this, simply hit one of the unsolved corners twice, once to get it into the prime position, and once to get it into its correct final position and orientation. In our case, our sequence will be H, followed by S. Now all of the corners in the cube are solved. At this point during the solve, you will either use the parity swap algorithm once or skip it. If the number of corner swaps you have performed thus far is even, you will not use the parity swap algorithm. If the number of corner swaps you have performed thus far is odd, you will perform the parity swap algorithm. Therefore, during the preparation of the solve, you must keep close track of how many corner swap algorithms you have performed in order to determine if the parity swap algorithm is necessary. The old Pochmann technique also applies to the edges. Notice that at any given time, each of the 12 edge pieces will occupy one of the 12 possible positions for an edge piece with a specific orientation. By using the old Pochmann technique, we can move each edge to its final position by using a mini algorithm to move the piece in the final position to the hit position, performing the edge swap algorithm, then reversing the mini algorithm just like we did for the corners. Remember to keep track of the pieces that you have solved by lightly placing your finger on them during the preparation phase so that you know which unsolved pieces to hit if your prime position piece has returned to the prime position or pieces are in the incorrect orientation. Now I'm going to do a step-by-step example solve with just the pieces in the top row of the cube. I will scramble the cube with the following algorithm. First, we look at the corners. We can see that the piece currently in the prime position belongs in F, so we record the letter F and mark the piece with our finger. Next, we observe that the prime position piece is in its final position, so we record one of the unsolved corners such as D. D then hits to J, which hits to R. At this point, all of the corners with the prime position are marked as solved, which means that all of the corners are solved. Because so far we have F, D, J, R, an even number, the parity swap algorithm is not performed. Next, we look at the edges. The edge currently in the prime position belongs in D. D belongs in A, so we record the letters D and A. However, because the edge in C is already in its final position, all of the edges marked by our fingers are now marked by our fingers, and so now we are complete with the cube. Our sequence is currently F, D, J, R, D, A. Although the sequence for now is short because we only scrambled the top row, mnemonics can still be helpful to assist memorization. F, D, J, R can be converted into food, jar, and diary. Therefore, you can envision a food jar full of dairy products, ingrain this image into your mind during the preparation part of the solve, and use this image to help you recall the letters during the solve. I will now execute the sequence F, D, J, R, D, A as if I was blindfolded. As you can see, the top layer of the cube is now solved. Now you have learned everything you need to successfully solve the Rubik's Cube blindfolded. The only thing left to do now is to practice the swap algorithms and mini algorithms, as well as the process of analyzing the cube and recording and memorizing the sequence of letters. Although it will be difficult initially, after a while it will become second nature. I wish you the best of luck, and thanks for watching.